Okay, 3, 2, 1, let's go. Kia ora, everybody. Welcome back to Stuff That Matters Now. Today, I am about to have an interview that I think is possibly the most important podcast I've ever done. There you go, putting a stake in the ground. And I am welcoming Anita Derks. Anita, thank you for joining us.
Thanks, Harv. It's a pleasure to be here. I'm looking forward to the questions you've got for me.
There's plenty. And before we start, Anita, talk to me like a Labrador, okay? We're getting into some technical stuff today. So, why is this so important? Because today I've got the pleasure of talking to somebody who is in the midst of, in her world, of producing vaccines.
That's correct.
And this is a subject that has become very sensitive in the last few years, and so I was dying for this interview to go, let's get to and talk to somebody who actually makes them. Anita, what are you?
I'm a microbiologist, and I operate as a biotechnologist in making pharmaceutical products, mostly biologics, and mostly vaccines.
How many of you are there in New Zealand?
Not too many, I would expect. We've got very, very limited manufacturing and very limited biologics or vaccine manufacturing for anything in New Zealand. So I currently work in a facility where we make animal vaccines for livestock.
You've worked all around the world?
I have indeed.
And Anita's told me we can't talk about the multinationals she's worked for, but we can talk about you've worked a lot in Europe and in other areas around the world.
Yeah, that's right. So I've started my career in New Zealand in the 80s. In New Zealand in the 80s, we did have pharmaceutical manufacturing, and we did have a couple of places that make veterinary vaccines, and quite a range of those. We still have a couple of businesses that make the animal vaccines, but we have almost nothing in New Zealand for human health. And that's a shame. So one of the most famous places that's been sold off to a big multinational is Glaxo, and that's a Palmerston North business initially. And you'll know all about GSK in the world scene for pharma.
Interesting. I'll drive past the old Glaxo factory on the way home tonight. Yep. And it's sitting there being used for some contractors or something now.
Yeah, something like that.
Yeah.
And I must say it's recent news, but it's really sad to see that a lot of the brains trust from Callaghan Innovations will be disappearing from the country as well. That's our crucible, or that's our invention ground where we come up with these new amazing things that can save lives.
Very, very sad that Sir Paul Callaghan was a local boy, Wanganui, very down-to-earth dude, had big aspirations for New Zealand, and I think he would be turning in his grave right now, looking at what's happened with the innovation science in New Zealand.
New Zealand is an amazing country where we have a huge legacy of invention and innovation that is now built into products and built into systems all over the world. And they're medicines and things that we use today that were invented in New Zealand.
I've got an interview sometime this year, Anita, with a chap working in genetics, and he's developed, along with others in Dunedin, out of the university, some wonderful new for animal genetics. Cannot get support here, and so he's going to Sweden. And just anyway, slightly off topic.
Yep.
Anita, your accent's a bit different. Tell us about that.
The accent is different largely because I started work and I grew up in New Zealand, but I also spent a few years growing up in Canada. I lost that accent by the time I left New Zealand again and moved to Australia, where there was a lot more opportunity for microbiologists. So I followed an R&D career into making and developing animal vaccines in Australia. And from there, I moved to the US for a short stint, and then to Switzerland for quite a few years, and then back to Australia. And now here I am home again in New Zealand.
All grown up.
Yeah, after a career in pharma.
Welcome home. Anita, what gets you interested in this field? Like going right back to when you were a kid, what was that about?
I was always interested in little things that you couldn't really see. So when I was 11, I made my first Van Leeuwenhoek microscope, which was a little block of wood with a hole in it and a little mirror, and looked at things that I found all over the place and tried to imagine what it would be like. Also, when I was very young, I was highly influenced by my mother, who was a nurse, and she talked about vaccines and how wonderful it was, how they saved lives. So I was interested from that time in vaccines, and having my first smallpox vaccine when I was 10 as we went to Canada was quite an experience, and I thought, I need to make these things.
Wow.
Yeah, so things that you can't see interest me.
Right, okay. And that's a lot of stuff we can't see.
Mm.
I'm going to guess, so what was at school, what was your strength at school? What was the stuff that you were really good at?
Math. Yeah.
Really?
Math, and geography, because I'm interested in people and populations and how things work.
And so the maths, I wasn't expecting that. I was thinking it would be. So does maths come into the world of vaccines?
Maths comes into everything, and maths is all about, and physics are very important everywhere, as is chemistry. So they're building blocks, but that doesn't help explain bigger things such as biological things. It's a compilation of all of those things put together. But understanding math is really very, very important in being able to get a concept from an idea, or have a concept, and then make it into something really that does work, such as making vaccines in a 30,000 litre fermenter, and how to scale that up.
Right. Got it. Okay. Yep, that one's just clicked. So you studied what at university?
I studied microbiology as a major, and I did honours in microbiology at Otago. And then more recently, because of my interest in health and human health and populations and so on, I did a postgrad diploma in public health management, also at Otago.
And so vaccines essentially to you fit into the health industry?
Yeah, vaccines are the only things that mimic a bug in a safe way. So one of those things that you can't see, viruses and bacteria, are going all over the place from various ways and means. They've got ways to travel. And vaccines are the only things that will stop you getting the disease.
As a microbiologist, you could have gone in any direction, lots of different directions.
Mm-hmm.
So you might have already answered this already, but what was the thing that went, this is what I want to work on?
It was looking at why people got sick in the first place, and knowing that if it was bacteria or viruses, that why on earth was there no vaccine to help them stopping getting sick?
Yep. Okay. So that's where it came from. We've talked about animal vaccines. Have you worked in the human vaccine space as well?
Yes, I have. So I spent a bit of time setting up a 9/11 project for smallpox vaccine, to make sure that there was sufficient doses around the world in case there was a bioterrorism relating to smallpox. Went to the US for that and set that factory up and produced something like 60 million doses in a very short time.
Okay, that's a bit left field. Right, so 9/11, you had the terrorist attack, and this was in response to going, what else could happen?
Yes. And then that led on to providing support for some other human vaccines as well, but I wasn't directly making those. I just helped and advised around the edges on how to make them most effectively, and that includes a recombinant human influenza vaccine as well.
What are you good at?
Talking.
Yeah? At work, what are you good at?
I think my strength at work is leading people.
Right.
I'm not the smartest person around, and I think cleverness is a function of a bunch of people working together on a single purpose. So
Yeah.
I like driving people to a single purpose.
What's been the biggest surprise from when you started into the industry of vaccines? What's been the biggest surprise for you through the years?
I think that the constant learning that I have is that no one person knows everything. And if you can get even 5 or 10% of your concept understood and carried through to the rest of the organisation or business, I think that's a real win.
Well, that's not very much, 5 to 10%.
Well, there's so many vested interests and there's so many other ways of looking at things. So there's no one way to solve a problem. There's lots of ways. And if you combine all those 10% from all the contributors, then you have an idea, you have a way of making it, you have a way of presenting it, you've got a way of making sure it's safe. And then you need sales and marketing, of course.
Right.
Because everything costs. And it costs time and it costs money to result. Yep. And energy and a driving force.
Have you worked on a project that just ran at a puff?
Yes. They happen. And I think this is the thing about science. If you've got 20 ideas that you're working on and that look really promising, maybe one will make it. And that one is usually not a fantastic answer, but it's an adequate answer.
Right. What would be... So if we move to human vaccines, which have had just the most amazing amount of attention since 2020, tell me about what you've learned about human vaccines from the beginning of your career, the impact on humanity.
I think that the most important story is how it started with Jenner in 1797 or thereabouts, when he figured out that the milkmaids had beautiful skin and they looked fantastic, and they were the only ones in the community that in towns that had a flawless complexion. And he worked out that they had little scabs now and then, and it was cowpox. Cowpox protects against smallpox. And he was the first person that protected his family by grinding up some cowpox and scratching it onto the skin of his family, and none of them got smallpox when there was an epidemic. It's thought that 90% of the population of South America died from the common cold, as we call it, or the influenza and smallpox when the Spanish conquistadors went to South America. 10% survived.
Yep. Look, I saw a speech by a professor talking about human population and lights coming on and off, and one dot was 1 million people. And I remember he showed this, it was a wonderful thing. and it was a little video, and he said, now here come the Spanish into South America, and all of these lights went off. And apparently that was the first recorded of Anthropocene, that the climate shifted because so many people in South America died that the Amazon grew and affected the climate. So that was the first record. It was a positive result, but just, that must have been just horrific.
Yeah. And also, even more recently, if you have a look at the child mortality rate in countries where there's no children's vaccines, is very high, related to diseases that are totally preventable, such as pneumonia and the normal childhood diseases. Even in Europe in the 1900s, there'd be very few children get through to the age of 5 unscathed. And when they did get the diseases, even whooping cough, they were sickly for the rest of their lives. That's a shame.
Okay. Can you paint a picture of what humanity would be like without vaccines today?
The population would be growing a lot more slowly.
And our general health would be
Worse.
Yep.
And it's not just because of the vaccines, but when you have medicines that so-called help you, they all have side effects. So vaccines don't really have side effects, but the medicines do. So you're still going to be sickly if you don't get the right treatments at the right time. And nowadays we've got multi-drug resistance in bacteria. So if you do get sick with certain bacteria, that antibiotics won't help.
Has there ever been a resistance to vaccines showing up?
No.
Because why?
Because it's your own body fighting that disease. And if you're vaccinated, your body's seen that bug before, so it puts all out to protect against it.
So just explain to me. So, okay, here's an example. I'm 65 this year, and so I am able to have a free shingles vaccine, which I've had before. And shingles just terrifies me. My grandfather had shingles, and huge impact on the rest of his life. So I'm going to go in for a shingles vaccine this year. What happens in my body when I get that vaccine?
Well, if you've had chickenpox as a child, you will have the virus sitting in your spine, in the nerve ganglia, as they're called, down your spine. And when you get older or when you're going through stress, those viruses pop out and cause shingles, which is a type of chickenpox, really.
Yep.
What the vaccine does is it stops them from proliferating and causing the effect of chickenpox. Better still, if children are vaccinated with the chickenpox vaccine, I forget what it's called, then it stops the need for having that shingles vaccine, and it stops the risk. However, I don't know what the duration of immunity is for the chickenpox vaccine in children, and it might be necessary to have a vaccination every 20 years or 10 years or whatever.
Yep. And I'm due for my tetanus one, which is every 10 years as well.
Yeah, no, that's a good one to get.
Yep. How many vaccines are available to humans now?
There's only about 33 diseases that have vaccines to be protected against.
So that's across the world, 33. Okay, it's a bigger number than I was expecting, 33. And if you had a choice between a vaccine and medicine, which would you take?
I'd take a vaccine any day.
Because?
Because it's safe and it's protective.
Okay, so let's go to this area where people think, let's go to the COVID vaccine, where some people have this fear of the vaccine that it wasn't safe or is not safe. What's your response to that?
I am such a big fan of vaccines. I've had all the COVID vaccine doses that I can possibly get. I had COVID once, and I do not want to get it again. I was pretty sick in bed, and that was after 3 doses. The vaccine has a very, very short duration of immunity, and the virus is changing all the time, a little bit like the influenza virus. It's changing all the time. I don't think the health departments in the world or the health authorities have got it together yet to have such a good system to provide recent strains in the vaccines on a regular basis for for the COVID compared to the influenza vaccine. I think it's very safe, extremely safe.
So the vaccine seemed to the public to be formulated very quickly, and people were suspicious that this thing had come together so quickly. What's your response to that?
I think the science is at a very, very high level where we've got genetics and we've got replication techniques that are really, really good and very, very reliable. The basis of one of the COVID vaccines, the one that's used the most today, was the basis of the the Ebola vaccine in West Africa, where they needed something that they could link on to something that was easy to make and replicate it very quickly. A little bit like DNA testing and PCR, when you get forensics testing and you can replicate up a little piece of DNA very quickly and say, oh, it comes from this person.
Right.
We can do the same in making vaccines.
Right. And so to you, it didn't seem suspicious that they were able to get this vaccine developed at the speed they did?
No, and it's a little bit like my smallpox experience making 60 million doses in 6 months. When you pull enough people, and I pulled a team of 23 together, all up for the site, we had a team of 200 within the space of 2 or 3 weeks, and we just ripped into it. And it's the same thing with making a pandemic response vaccine. You put all the best people in one place and you coordinate it with the governments and you can make it happen. We had weekly meetings with the US FDA, CEDAR and CBER, to make sure that they were happy with the track that we were taking. So that's a really highly developed inspectors that knew their stuff and they knew what risks there were, and they were very happy with it. And the same applied to the fast-track development for the COVID vaccines.
How do we know it's safe, Anita? How do we know it's safe?
The statistics, and that's where mathematics comes back into it. The statistics tell us that this is an extremely safe vaccine.
I'm playing devil's advocate here because on Facebook, and are we allowed to talk about the specific makers of the COVID vaccine, or should we stay away from that?
Well, I don't think it really matters.
Okay.
I don't think it really matters at all.
Okay. So right now, I saw on Facebook that there are lawsuits being taken against a particular company for harm to people's hearts and to children and stuff like that. Mm-hmm. And I mean, these have only just been served, so I have no idea the outcome, obviously.
Yeah.
What would you say to that?
The first question I'd ask is, which country is this happening in?
In the United States?
Okay. In the United States, very few people have access to healthcare. It's insurance-based. The average spend per person in the US per year is $15,000 US. New Zealand spends about $6,000 US, and yet most people have no access to it, very few. So if you want to get treatment and you can find a way...
Hang on, stop. US 15,000?
Mm-hmm.
That's what the government spends per person?
That's pretty much what the government spends per person, yep.
And we spend 6,000?
Correct.
They don't have a public health system.
Correct.
We do.
Correct.
How the fuck does that work? Where does that 15 grand go to?
I have no idea, but it's not used effectively compared to what's happening in New Zealand.
That's cool.
That's cool.
Sorry.
We've got a very efficient health system, and yes, we can rip holes and rip shreds into it. If you're prepared to pay more tax, I think we'd get a better healthcare system. We're very efficient.
That's a wee surprise to me today, Anita. And look, okay, I'm just absorbing that. That's because I am terrified that we've got politicians in New Zealand wanting us to go down more towards the American system.
That would be a disaster. That would be an absolute crying disaster, because it will not allow everybody to have the same access.
I'm just thinking, so $6,000 per person, okay.
Roughly.
Yeah, no.
In Canada, they spend about $8,000 per
Okay.
person, same with Australia.
Okay. Okay. All right. I have no idea where we were. That was just that. Okay. Going back to the American system then, of no 15 grand going into thin air somewhere. So that, as I said, this lawsuit was in America, and also the Americans love lawsuits.
Well, it's the only way that they've got access. So if they win the lawsuit, they might get enough money for their treatment. Whereas we don't need to do that. If you need treatment, you get it. And just putting it into context, the number of people with heart problems and kidney problems and liver problems and other problems after getting the disease is probably significant. It's probably significant because the effect of the disease is not well, I haven't read up much about it because I just wasn't interested. But I think the effect of having the disease has more implications than being the effect of the vaccination by a long shot.
So I'm really interested in people's biases, okay? You've got a bias towards having vaccines.
Yep.
But I'm guessing you're also pretty analytical.
I would say I am.
And so I'm trying to look through the lens of somebody listening to this who is sceptical of vaccines and trying to think what would they ask, questions they would ask. Because I've got a bias, Anita. I'm married to a doctor. I hang out with a lot of my wife's doctor friends, and they all get vaccinated. And they are all very happy with the process, and they've had their kids vaccinated and so. So I've got that bias because I'm in that world, and I know that bias is there, and I am very trusting of the health system. I'm not saying it's perfect and they make mistakes, but I also see, and this has been a big surprise being married to Kate, is how doctors scrutinise each other. They are ruthless in scrutinising each other and challenging each other. It's quite something.
That's very important too, because that means that there is discussion and debate and working for the right purpose.
Yeah.
Because I'll guarantee most of that discussion is how can we do it better?
Yeah. And also just challenging each other's beliefs. So that's been the biggest surprise, hanging out with Kate, is just how rigorous that is. And they seem to never let that go, even when they're socialising. They're very diligent in that space. With that whole COVID, and we're not going to get into psychology here unless you want to, but with the rollout, Anita, how could have the government in New Zealand done that rollout better?
looking back on my statement earlier where I said if 10% of your ideas can get through to the next level, I think if the government had listened a little bit better and debated a little bit better about what the communication strategy was and what the overall strategy was, full stop, normalised that kind of strategy with us as New Zealanders, and then being really careful to give those updates on this is what we're doing, this is why, and this is what we're getting back as information, and then tweaking it as they go, because there's no one way to do anything. I think if the government had been better at developing the communication strategy rather than just acting on the numbers on a daily basis, which was creating fear, to come up and find community members that would be influencers. Like Paul Revere.
Yep.
He was really successful because he had good relationships with every village along the way. So his message was disseminated very quickly.
Yep.
We should have used the same approach in New Zealand.
Yep. Which then brings me on to the next. We're going to have other outbreaks of stuff as climate change happens, as animals shift their terrain, as humans. There'll be other outbreaks. Yep.
There'll be other outbreaks because there are a lot of us, and there's more and more and more of us, and we're polluting our environment as we go.
Right. So these pandemics are going to become more often?
I don't know if it's going to become more often, but they'll spread faster.
Right.
I think there's always been horrible pandemics right through the history of people and of animals and of plants and so on. And there was nothing we could do to stop them. Now we've got technology, we've got vaccines that we can use to stop it.
So if you go back to the Black Death was happening in a certain part of the world, but other areas they didn't even know it was happening.
That's correct. And that was population based on fleas, and fleas holding the bugs that bit people and killed them.
Yeah.
Yeah. So it was based on poor hygiene, really.
Yeah. Do you ever look down the microscope at these things and go, that's a nasty thing?
I do, actually. Yeah. It's pretty amazing when you have a look at these things squiggling around on the slide, especially when you do a wet mount, and you can actually see them moving sometimes, and you just go, my goodness, no wonder it's so effective.
Right. So tell me about that. What makes an effective bug?
One that changes frequently, one that has a way of evading whatever their target is or wherever they end up, evading the immune system or the protections of that. So, for instance, tetanus doesn't really bother anybody until you get a rusty nail cut in your arm from a farm or something, because it's around everywhere. These Clostridia are, they help rot things and make great compost and decay things, and really I quite love those bugs because we make great vaccines for animals out of those.
Look, as a farmer, clostridial diseases were a nightmare, and it was amazing to watch an animal die and then just decompose so quickly. But thankfully, there were great vaccines there to do it. But I remember one year we used to have a thing called 3-in-1 vaccine, which covered the three big ones, and then one year we got sordilii, I think it was called.
Nasty bug.
Fuck, kill things, Trev. And I don't know where that came from. And then we had to use a broader spectrum
Vaccine. We've got there's a great 10 base on the market.
Yeah.
It covers 10 clostridials.
Yeah,
It's just amazing.
And but this sordilii, it was just and luckily it happened just in one. It was in cattle, in one herd of cattle, and
It kills the whole herd overnight.
Yeah. Yeah, well, we spread them out and got them vaccinated, and lucky it was only a small herd, but that was terrifying to see that thing come on.
Yeah, there was an incident in the early 1900s, 1930s, I think, around Gore, when a farmer lost all his sheep to novi, black disease, overnight.
Wow. Wow. In this, so 33 vaccines in New Zealand. How many would we be covered for?
I'm not sure, but most of them. So it's the common vaccines, such as the three-way diphtheria, tep, pertussis for children, polio. We don't have polio vaccination in New Zealand at the moment, I don't think. But it's really sad. When I was at primary school, my next-door neighbour, their son had a boy who was affected by polio, who's a few years older than me. It was awful to see, awful. He couldn't walk.
Yeah, I know a few people
Couldn't
have.
walk.
Yep.
Yeah. So things like rotavirus, measles, also pneumonia, the pneumococcus. There's a bunch of other vaccinations. Tetanus is very, very common, of course. And there are other vaccines that you can get when you're travelling. But, yeah, all those common people-based diseases that have vaccines are really, really good vaccines.
I overheard a conversation a few years ago. We had one of our collective intelligence members, a young woman, and she was pregnant. And another member was warning her from getting a flu jab because she was pregnant. And I was intrigued by this, and so I relayed this to a doctor and asked them, and they went, "Oh well, they need to know that 3 or 4 pregnant women a year die from flu in New Zealand." So it is it's a hell of a thing for a pregnant woman to get.
Yeah, and I would say that that's a unfounded kind of statement, because the vaccine is a killed vaccine. There's nothing live about it. And it's like being scratched with something and having an immune response to it. I just can't understand where that statement comes from.
But they're out there, aren't they?
They are. There's a lot of them out there. And it's the old wives' tales and the gossip, and a little bit of information is a really dangerous thing.
Yep. Because when you're talking about statistics before, you're talking about large numbers, right?
We're talking about a couple 100,000. Usually you put the adverse reaction rates at 0.01 in 100,000. So it's hardly anything.
Has there been a vaccine made when you do a test and go, "Oh no, this is not safe"?
They never get past stage 1. They never get past the concept. It's a very, very complicated process to get a new vaccine to market or any medicine to the market.
Can you talk us through that?
Okay. So it starts with research, and it starts with proof of concept. So you think you've got something that might work, and then you do trials.
Okay, just stop there. Labrador, okay. You think you've got something. So you're a bunch of scientists and you think you've identified something that's going to work. Yep. Mm-hmm. And that's taken a reasonable amount of work to get to there.
10 years or so, yeah.
Yep. How long?
10 years or so.
Okay, there we go.
We're
All
talking blue sky research here.
Got
it
it.
means you've got
I've got
nothing to start with, and you're just going, "Oh, look what I found."
Okay, got it. And sometimes that might be left field. Mm-hmm. Yep, okay. And we've seen, right, cool. Okay, next stage.
Then you do, for vaccines, you do some modelling with some fancy equipment and lab instruments, near infrared or atomic absorption spectroscopy. I don't know all these words, HPLC, which is a chromatography method, and you do some imaging. And then you'd have a look at the biological characteristics of this thing and how it would interact with targets. What could the targets be? Then you've got to figure out how to make more of it. And at a bench scale, you'd be looking at it in its effect on tissue culture. Now, tissue culture is when you get specialised cells from, the most common one that we use is Chinese hamster ovary cells. Yeah, it's amazing, those cells.
Okay. Keep going, we'll come back to that. Yep.
As an example, and you'd look at the effect. If that cell is a target cell, you'd look at the effect of your substance on the target cell.
So going back, you've imported these, or you've got hold of these as a test case when you talked about these
You're
targets.
creating them.
Yeah, okay.
You might you might be doing some work on a glioblastoma, for instance. It's a nerve cell cancer in the brain, or brain cell cancer.
Yep.
And you might pull one or two of those cells out and grow it in a bottle.
Yep.
And then have a look at the effect of whatever you're developing on those cells. Does it slow them down? Does it kill them? Does it kill the safe ones? Does it kill the good cells? Does it kill the bad cells, and so on? And you try that out on lots of different cell types.
This is all taking time. This is all taking a team of people and some very smart scientists.
Mm-hmm.
The cynic in me says, when does the commercial pressure come on to take it to the market?
A lot of companies have scouts that go to the universities and the research institutions, and they go to the symposia, they listen to what's going on, and they work out, this might be something very interesting. Let's go and have a talk with that scientific team.
Okay. So what you've explained before is mostly happening in universities and research.
Correct, yeah.
Okay, so this is just scientists doing scientisty things.
Yes.
Okay. I think that's a really important thing. And Anita, that's news to me as well, because I thought a lot of that would have happened in a commercial setting.
I think the COVID stuff would have happened in a commercial setting because it was a pandemic and it was of critical urgency. So all the governments put loads of money behind it to try to fast track something to save those thousands and millions of lives.
Yep.
But normally that is not how it happens.
Yep. And apparently there was a tremendous amount of collaboration happening and people opening doors and working together.
Yeah, absolutely.
Okay. So the rest of the time it is scientists working away.
And drumming up business, so to speak, making sure that they're presenting at symposia, making sure that they've got collaboration between laboratories doing the same thing, sharing and challenging each other. And that's the importance of a well-edited, challenged scientific paper, and in a respectable journal where they have good rapporteurs. Okay, let's talk about that. That's not talking about any Facebook or Instagram messages. Let's talk about that, because I've heard that as well, going, where has this been published? Has it been published and where is it published? That's a big deal, isn't it? It is a big deal. And there are thousands of papers published on many, many different topics where you can glean information, and it doesn't necessarily all fit together very well. There's some papers that I read and I'm just going, I don't think so. That's not very solid. And then other papers you go, my goodness, this is amazing. Yep. And you follow through that thread and look who they're collaborating with and make connections that way. Yep. And you could be wrong in your assumption. Correct. Yep. Mm-hmm. It is, and I've heard that as well. Yeah. Has it been published? Where has it been published? Yeah. And how many times has it been used as a reference and by whom?
Yeah. All that matters, isn't it?
It matters. Because it's about the kind of collaboration that you've just mentioned with Kate and her colleagues. It's all about challenging the status quo and digging into how much reality is in this versus how much supposition.
Yeah. Yeah. Anita, this is fascinating for me. Thank you. Yeah. And it's just because the thing is, it's so far away from my, I'm just imagining those scientists working away on, and a lot of that would be repeat work and repeat work and repeat work. Yeah.
Proof of concept, verifying it, being challenged, and then seeing if you can make it happen again.
Yeah.
And one of the really things that influenced me greatly was learning about Koch's postulates. And that's a guy, a real famous scientist, one of the first to make vaccines and proof of disease. So you have a disease, you pull out the bug, you say this causes the disease. You put it back into the animal or back into the test case and you go, yep, see, it causes the disease. And that's the fundamental thing, is how do you know that actually works to do what it's supposed to do? You prove it by putting it back, and there comes in the long pathway of drug development.
Right.
And that includes vaccines.
Right. Anita, what haven't we covered today? What you've got a list in front of you. What subjects have we not covered? And I wish we could take questions now, but we're not live because I know there'll be lots of questions. But I am going to encourage people to write in, because when we put this up, I would love people to be able to write in and ask questions of you from this interview.
Yeah, I think one thing that's really important to me is not only about vaccines, but how we keep ourselves healthy and what public health is. And that includes all sorts of things, and personal responsibility, including what the councils are doing for water and sanitation, clean drinking water, good waste removal, safe environment to live in, clean air. We're really fortunate in New Zealand. We have amazingly clean air.
Yep.
When I had some dinner with friends a couple of weeks ago, they'd just been to Delhi and they had to wear a mask everywhere, and they didn't realise that leaves were actually green on trees.
Right. Wow.
So we're really fortunate. Along with that is making sure that we're eating safely and that we're, getting plenty of sleep. So we've got a responsibility to protect ourselves as much as possible as well, and giving ourselves the best chance to prevent disease.
And yeah, that's a whole nother subject, isn't it?
It is. It's massive. And really, it's really what we're doing and how we're helped and educated into good hygiene and good personal hygiene and good family hygiene and so on, versus what we need to exist happily as people in families and in communities and so on, and playing sport and all of that sort of thing. So, we could stop all the diseases in the world, mostly, unless they come from chickens or something, if we didn't associate. But we must associate because we have it in our DNA, so to speak. It's part of us. That's why we are who we are.
Yep.
People are gregarious. People need people.
Yep.
So it's in that context, how do we protect our health, and how do we use things that will help us protect our health? And that's why I love vaccines.
Anita, you've spent a fair bit of time in Scandinavia.
Switzerland.
Yep. Is that Scandinavia?
No.
Isn't
it's
it?
in Europe. It's more southern Europe than anything.
It's a little bit. It's a little bit Scandinavia.
Not at all.
Oh, don't make me sound bad.
It's south,
Okay, all
south
right.
of Germany.
So, all right. Oh, God, yes. All right, okay. And here I was saying we're not going to edit it. I might edit that out. Okay, living abroad and coming back here, what do you notice when you come back?
I think that the biggest thing that I notice, I was out of New Zealand, pretty much not living in New Zealand for 30 years. Coming back, what I see is a lot of personal ownership and personal responsibility having been removed from our day-to-day actions. Let me just rephrase. In Switzerland, there were no barriers along the mountain roads to stop you from going over the edge.
Right.
In New Zealand, there are barriers everywhere.
Yep.
But they won't stop you from going over the
Yep.
edge. In New Zealand, I think we have an attitude of, I can do what I like and I don't have to worry because everything is controlled around me. I don't know if that's true or not, but it's a real shame. So that personal accountability and give it a go type attitude is diminishing.
There was some interesting research done sort of along the same lines around the difference between safety of traffic lights and roundabouts. And roundabouts are far safer than traffic lights because when you go into a roundabout, you've got to concentrate and there'll be different lanes, and going into lights, you just do what the lights tell you.
Yeah.
And I was gobsmacked when I heard it's a lot safer. And
Untold safer.
yeah, and that's what you're talking about, isn't it?
Mm-hmm.
That having more roundabouts and that we need to stay aware, conscious of what's going on.
Yeah.
Yeah, because growing up for me, jungle gyms, we didn't have anything at the bottom of the jungle gyms. There was no
Tarmac.
pads. Yeah.
No sand, nothing.
There was no sand. It was either on grass or it was on concrete or tarmac. I'm not saying that was right, but there's a lot of, you go to a playground now and it's almost overdone in some respects.
Well, we all learnt swimming in the local primary school concrete swimming pool, which was about 3 feet deep.
Yeah,
We all learnt to swim in those.
yeah,
And it was unheated water.
yeah,
I don't see many of those swimming pools around anymore, and I wonder why.
yeah,
And we also have more drownings.
yeah, yeah. Anita, anything else on your list?
Just that I think New Zealand's slipping behind our peers, countries that we look up to, in the vaccination rates and the amount of disease, especially in children. And I would really like to see more early childhood vaccination happening to protect those fragile little ones who are our future. Because that makes sure that they don't live a frail life after getting a disease, and it gives them all the best opportunities for a healthy, long life.
That's pretty clear, Anita. Yeah. What would you say to mothers and fathers that are reticent about getting their children vaccinated?
Seeing your child sick with the disease is gutting. If you can avoid seeing your child sick with a disease that could be easily prevented, go straight to your GP. Go and get some advice. Find out what you need to know, and please get your children vaccinated.
Anita, thank you for doing your work and keeping humans and animals safer. I've learnt a lot today, stuff I wasn't expecting. And for people to look on the map, Switzerland is part of Scandinavia. It's moved. But seriously, the biggest surprise to me today was that gap between America and New Zealand about what we spend on healthcare. And I agree with you. We're not paying enough in tax in New Zealand, and it's something that we need to understand the impact it has on our health system and key things like that. As the population grows, as the demographic changes,
Yeah, and the cost of health in 1960, about 1% of GDP was spent on health, and now it's a lot more than that.
yeah. Anita, thank you. Thank you for your time. Keep up the good work.
Thanks, Harv. Great talking.